5.1 goes over angle measures. We're doing this in two parts. Today we're going to first focus on what an angle is and how to get it. So there's two sides of an angle. One that's an initial side, one that's a terminal side. An initial side is where that angle starts at. It's one that does not move. Your terminal side is the side that moves. So if you are moving counterclockwise from your initial side, that's giving you a positive angle. If you're moving clockwise from that terminal side, that's giving you, from that initial side with your terminal side, it's giving you a negative angle. This is exactly the same thing that we just went over. So with these measures of an angle, the amount of rotation that you have is coming from the vertex. A lot of times with these angles, you're going to be looking at the degree of the angle, and it's normally out of 360. A full rotation gives you a circle that's a 360 degree angle. Another way to represent these measures of an angle is in radians. So you're going to be going back and forth between degrees and radians and degrees, which we will get to. But a radian is literally, so it tells you that if a circle of a radius of 1 is drawn with a vertex of an angle at its center, then the measure of the angle in radians is the length of the arc that subtends the angle. That just means that your radian is from a certain part to a certain part within the angle. It's that measure that is the outer part of that angle. With these angle measurements, your circumference of the circle of the radius 1 is 2 pi. So a full rotation of your angles 360 degrees is the same exact thing as 2 pi radians. Half of that, which would be a 180 degree angle, is just pi radians, and then a 90 degree angle would be pi over 2 radians. In order to convert degrees to radians, you're going to be multiplying your degree by pi over 180. The 180 and your degree will most likely simplify, and then you multiply straight across, making sure you have that pi within your answer. If you're told to convert from degrees to radians, pi must be included in your answer. So a good way to remember these on which one to use is that if you're converting into radians, pi must be in your answer, so pi has to be in the numerator of the fraction that you're dividing by. So it would just be pi over 180. To convert from radians to degrees, you want to get rid of the pi, so that pi would have to be in the denominator, and it would just be 180 over pi. For example 1, we're just converting back and forth between degrees and radians and degrees. For example A, we have 60 degrees, and we're representing that in radians. So we're going to start with 60 degrees. We're going to multiply that 60 degrees. We can put it over 1, multiply it by, we want to end with pi, so that's pi over 180. That 60 and that 180 both have a 0. They cancel out. 6 goes into 18 3 times, so that is just pi over 3 radians. For example B, we are given pi over 6 radians, and we want to turn that into degrees. So we want to get rid of that pi, so that pi is going to have to be in the denominator. So it's just going to be 180 over pi that we're multiplying that pi over 6 by. From here, your pi's cancel. 6 goes into 180 30 times, so that's just 30 degrees. With these, you want to remember, if you're representing your answer in degrees, you got to keep that degree symbol. If it's in radians, you got to write out that radians are abbreviated as RAD. For example C, we're given negative 7 pi over 12. We want to get rid of that pi and turn this into degrees. So we're going to multiply it by 180 over pi. The pi's cancel. The 12 and the 180 are both divisible by 4, so 12 turns into 3. 4 goes into 18 4 times with 2 left over, so 20. 4 goes into 25 times, so that's 45. So we're just doing negative 7 over 3 times 45 over 1. Now, hold on one second, because the 3 and the 45 can simplify to be 1 and 15. So we're doing negative 7 times 15, which gives us a negative 105 degrees. For example D, we have 952 degrees. We're going to put this over 1, and we're going to multiply it by pi over 180. We want our pi with our answer, so it's got to be in our numerator. From here, we can simplify that 952 is divisible by 4. That 180 we said was divisible by 4. So this 952 becomes 238. 180 becomes 45. So we're just doing 238 times pi over 1 times 45, which leaves us with 238 pi over 45 radians. And again, you can abbreviate it and just write out that RAD. The next part of your measure just goes over the terminology with these degrees and radians. It tells us that we often use the phrase such as a 30-degree angle to mean an angle whose measure is 30 degrees. Also, for an angle theta, that little 0 with a line through it, it's called theta. We write theta is equal to 30 degrees or theta is equal to pi over 6. This just means the measure of theta is 30 degrees or the measure of theta is pi over 6 radians. When there is absolutely no given unit, so there's no degree and there's no radian on it, it's just assumed that it's in radians. An angle is drawn in standard position if it's on something that looks like a coordinate plane, so an XY plane. The vertex will always be at the origin, and the initial side will always be at the positive x-axis. These different figures here give you examples of standard position angles on an XY plane. As you see, all of these angles have an initial side that starts on the positive x-axis. If it goes up, so counterclockwise, it's going to be a positive angle, and that terminal side is going to be given to you using that positive angle. If it goes down, it will be a negative angle. If it goes clockwise, it will be a negative angle. But again, as you see here, every single one of these angles starts at a positive x-axis. So that initial side is on the positive x-axis. Then the terminal side is just what moves to give you that angle. In this last example, example A and example C are coterminal angles. So in total, the one that's positive plus the one that's negative would give you a full 360 degrees. Two angles in standard position are coterminal if their sides coincide. So if we look here, so the next part that we're going to be looking at is finding coterminal angles. With these, you want to add 360, you want to subtract 360. So you're going to add 360, you're going to subtract 360. That's if it's given to you in degrees. Remember, as radians, 360 degrees is 2 pi. So if it's given to you in radians, you're going to add 2 pi or you're going to subtract 2 pi. Now with these examples, you got to be careful with them because sometimes your directions will just tell you to find the coterminal angles. Sometimes it'll tell you to find a positive coterminal angle and a negative coterminal angle. Sometimes it'll tell you to find 2 coterminal angles that are positive, 2 coterminal angles that are negative. It all depends on what your directions are. For all of these, we're just going to be finding the positive and the negative coterminal angles for each of them. So an example A gives us 360 degrees. It's in degrees, so we add 360 to this, and we also take the 360 or the 30 degrees and subtract 360 from it. So it'll give us 2 coterminal angles here. If we add the 360 to it, it gives us 390 degrees. If we subtract 360 from it, we're left with negative 330 degrees. So the two coterminal angles for 30 degrees that are positive and negative are 390 degrees and negative 330 degrees. Now you could keep going with this and give multiple coterminal angles, as long as the one, if you're adding, let's say you add 720 to the 30 degrees and you get something, you're going to have to subtract the 720 from it as well. For example B, it tells us to find angles that are coterminal with the angle theta is equal to pi over 3. So this pi over 3 tells us it's in radians. If it's in radians, we're adding 2 pi to it and we're subtracting 2 pi from it. So we're going to start with pi over 3. We're going to add 2 pi to it. So it's 2 pi over 1. We're also going to subtract 2 pi from it. Remember, when you're adding and subtracting fractions, you need like denominators. So that 2 pi over 1, when you're adding it, you're going to have to multiply top and bottom by 3. So that's pi over 3 plus 6 pi over 3. This is going to give us 7 pi over 3. For the 2 pi minus, or 2 pi over 1 that we're subtracting from pi over 3, multiply the top and bottom of that 2 pi over 1 by 3. So this is giving us pi over 3 minus 6 pi over 3, which is just negative 5 pi over 3. We have a positive, we have a negative. These are both radians. So our two coterminal angles for pi over 3 radians is 7 pi over 3 radians and negative 5 pi over 3 radians. For example C, we're given that theta is negative 170 degrees. So with negative 170 degrees, I'm going to write this down twice. I want to add 360 to this, and I want to subtract 360 from this. If I add 360 to it, I have 360 minus 170, which is 190 degrees. And if I subtract 360 from it, 170, 360 is negative 530 degrees. So your two coterminal angles, both positive and negative, for a negative 170 degrees is 190 degrees and negative 530 degrees. For example D, we're given that theta is 18 pi over 5. So with this, we're going to add 2 pi to this, and we're going to subtract 2 pi from it. So we're looking for a positive and a negative with this. Oops. Minus 2 pi over 1. Again, we need like denominators in order to add and subtract these. So we're going to multiply that 2 pi over 1 by 5 on the top and the bottom. So this is giving us 18 pi over 5 plus 10 pi over 5, as well as 18 pi over 5 minus 10 pi over 5. Working with the one on the left, 18 plus 10 gives us 28. Keep the pi, keep it over 5. That's a positive one, so we have one coterminal angle. For the 18 pi minus 10 pi, that gives us 8 pi over 5. Now, if your directions are not specifying a positive and a negative coterminal angle, you can give that 8 pi over 5 as a coterminal angle. However, if your directions tell you you need a positive and a negative coterminal angle, you would continue to subtract 2 pi over 1 from this in order to get that negative coterminal angle. So if we're going to subtract 2 pi over 1 from this, multiply top and bottom of that 2 pi over 1 by 5, it gives you 8 pi over 5 minus 10 pi over 5. So this leaves us with negative 2 pi over 5 radians. And again, this is the negative, so that one is a coterminal angle. That's positive and negative for your 18 pi over 5. The next part that we're going to be going over today is arc length. So in a circle of the radius r, the length s of an arc length that subtends a central angle of theta in radians is S is equal to R times theta. Your S is the arc length, your R is your radius. And your theta is always given or used in radians. So if we were to solve for theta, we would just have theta is equal to S over R, where S is the arc length and R is your radius. Looking at an example, it tells us to, for example A, it tells us to find the length of the arc, so we're finding S, of a circle with the radius 10 meters that subtends a central angle of 30 degrees. First off, this angle is not in radians. You want it to be in radians. So we're going to have to first transform the 30 degrees into radians. Oops. So 30 over 1 times pi over 180 gives us pi over 6 radians. So if our angle is pi over 6 radians, that means that theta is pi over 6a, gives us that theta is pi over 6. It also gives us that our radius, our R, is 10 meters. We want to find what S is. So if we want to find what S is, we said that before this slide, that theta is equal to our S, our side length, over our radius. So plug in your values and solve for S. If theta is if theta is pi over 6, we're finding S and R is 10. Multiply each side by 10. These cancel. The 6 becomes 3. 10 becomes 5. 5 times pi over 3 gives us S is 5 pi over 3 radians. For example B, it tells us that a central angle theta in a circle of a radius 4 meters is subtended by an arc length of 6 meters. Find the measure of theta in radians. So remember, theta is equal to our arc length divided by our radius. It tells us that our radius is 4 meters. Our arc length is 6 meters. So plug these values in. Theta is equal to 6 over 4. Simplify this. That's 3 over 2 radians.